All right, let's break down what has to be one of the most incredible feats in all of engineering: landing a rocket backwards. I mean, you've seen the footage. It looks like a movie playing in reverse, something straight out of science fiction. But how in the world is it actually possible? So let's just jump right into the core of the problem, because it's a wild one when you really think about it. How do you take an object the size of a skyscraper, drop it from the very edge of space, and get it to land so gently on a tiny little pad that it's actually ready to fly again? You know, to really get your head around how difficult this is, engineers love to use this analogy, and it is perfect. It captures the two huge challenges all at once. You've got the crazy instability of a tall, skinny rocket, and you're dealing with the absolute chaos of re-entering the atmosphere. Okay, so before we even get to the solutions, let's just take a second to appreciate the sheer scale of the problem we're trying to solve here. The numbers we're about to look at are, well, they're out of this world. So right after it's done its job, that rocket booster is screaming through space at Mach 25. That is 25 times the speed of sound. It's going so ridiculously fast that when it finally hits the upper atmosphere, the friction literally turns the air around it into a blazing hot plasma. And it's starting this fall from about 100 kilometers up. We're talking about the Kármán line, the official boundary of space. It has a mind-boggling amount of energy that somehow has to disappear before it can ever hope to land. And on top of all that, the booster is just plain enormous. It's about 70 meters tall, so taller than a 20-story building. And here's the kicker. Its center of mass is super high, which means it naturally wants to just tumble end over end all the way down, just like that broomstick we were talking about. So you've got this unstable 20-story building. It's falling at hypersonic speeds from the edge of space. The very first problem is just, how do you even begin to slow it down? You've got to start hitting the brakes before there's even any air to help you out. And the key to this whole thing is a concept called retropropulsion. Basically, you're using the rocket's own incredibly powerful engines to fight against its own momentum. You're literally firing the engines in the direction you're traveling to slam on the brakes in the total vacuum of space. Now, this isn't just one long engine fire. Oh no, it's this incredibly precise 3-act ballet. The first step, that's the boost back burn. It flips the rocket around and basically aims it back towards the landing zone. Then, step 2, the re-entry burn. Fires right as it hits the atmosphere to act like a fiery brake and protect it from the intense heat. And then, step 3, well, that's the landing burn. The grand finale we'll get to in just a minute. Okay, so once the rocket starts hitting that thicker atmosphere, just slowing down isn't good enough. Now you have a whole new problem. You have to steer this thing with absolute pinpoint accuracy while it's falling through the sky like a giant metal dart. And this is a huge, huge problem, because a rocket is built to be aerodynamic going up, not coming down backwards. I mean, it has no wings, no traditional rudder, none of the control surfaces you'd find on an airplane. It is fundamentally unstable coming down. So what did engineers come up with? This absolutely unique, brilliant piece of hardware: the grid fin. You've probably seen these things that look kind of like waffle irons on the side of the rocket. They're made of stuff like titanium so they can handle the insane heat, and as air rushes past them at supersonic speeds, they can tilt and move to create massive steering forces, literally guiding the rocket on its way down. Now, what's so cool about these fins is how different they are from a normal wing. See, an airplane wing is designed to create lift, to push the plane up. A grid fin does the exact opposite. It's designed to be leaky, to let air pass through it. This creates enormous drag and powerful steering ability without creating any unwanted lift that could throw the rocket completely off course. So, steering this thing is actually a two-part system. You've got the grid fins making the big, broad adjustments, kind of like the main rudder on a ship, and at the same time, the rocket's own engines are swiveling or gimbaling back and forth, making all those constant, tiny little corrections you need for that absolute precision. All right, the rocket is on its final approach. It's slowed down from Mach 25, it's steered itself all the way through the atmosphere, it's aimed right at the landing pad. Now comes the grand finale, the most critical, nail-biting few seconds of the entire flight. This final technique has the best name ever, the hover slam. And the name tells you everything. The rocket doesn't just gently hover down to the ground. That would waste a ton of fuel. Instead, it free falls at high speed until the very, very last moment. And then it slams on the engine brakes to come to a perfect stop right as it touches down. There is absolutely zero room for error. And this all happens in a blur. The flight computer figures out the perfect split second to light that final landing burn. And that one burn has to do everything at once. It has to kill all the downward speed, kill all the sideways speed, and guide the rocket to the dead center of the pad so it touches down perfectly. And this quote just brilliantly sums up that final challenge. The precision required is almost impossible to comprehend, and it's only possible because of these incredibly powerful flight computers, making thousands of calculations every single second, adjusting the engines, adjusting the thrust, all while this thing is just falling out of the sky. So let's just step back for a second. Engineers took this seemingly impossible problem, a hypersonic, unstable skyscraper falling from space, and they just solved it one piece at a time. They used retropropulsion to hit the brakes, these ingenious grid fins to steer, and that high-stakes hover slam to stick the landing. Just an absolute masterpiece. And really, that's the thought I want to leave you with. This achievement just shatters our ideas of what's possible, and it completely changes the game for space travel. It just makes you wonder, right? If we can teach a rocket to land itself backwards, what's the next impossible challenge that we're going to solve?